This week, as part of my DSA studies, I had to learn about heaps and tries, along with other data structures like graphs. So, in this video, I'll be talking a bit about what I learned about heaps and also tries. So, first, to learn about heaps, we have to know what trees are. Okay, because heaps are a special type of binary tree in which there is a specific rule that they follow. So first we have to know what there are two different types of trees. Okay, three different types of trees, and these are complete, full, and incomplete trees. Okay, so a complete tree is a tree that does not have any holes in between. So when we take the array representation of a tree, in a pictorial representation, if you know what trees are usually represented as nodes going from one place to the other. Like there are nodes and then there are edges that point to other nodes. That is the pictorial representation. But when we want to represent trees, there is programmatically one of the easiest way to do this is to use arrays. Okay, so we just store the elements in a specific way. So what we do is the parent element of any element is n by 2. That is, n will be the index, or I by 2, and that will give us the index of the parent of this specific node. So we will do floor division obviously, because if the index is 3, then if we divide it by 2, it will become 1.5, which is not a valid index. So we will do floor division, and whenever we get any index, if we want to find the parent of that node, we can just do an I by 2, and we can access the parent. And when we want to access the left child of the node, then we just do 2n. that will be the left child. 2 times the current index of the element will be the left child of that node, and to get the right child we just do 2n plus 1, so that will give us the right child. So in this way we can represent trees in a very simple manner, while also making it easy for computers to understand. And when we convert a tree to an array, there can be holes in between or some spaces in between that are not filled. So this is called an incomplete tree. So this is should never be the case in the case of a heap, because a heap is a tree but also it is a complete tree. So what we will have is a node here, and then the next node is supposed to come, because if you represent just one node in an array, that means it will be at index 1. If you're taking a 1 based index, not 0 based indexing, then the first element will be at 1, right? So that means the second element will be at 2n, that is 2. So 2 times 1 is 2. So the second element is supposed to be at 2, third element is supposed to be at 3, and so on, right? And like that, when we represent, there should never be any holes. If there are holes, then that means that tree is not complete. And a full tree is a tree in which each level is completely full, like there is no missing element in that level. So in the first level you can have at maximum 1 node, in the second level you can have at maximum 2 nodes, and in the third level you can have at maximum 1 2 3 4 4 nodes, right? So in a full tree there will be one element in the first, and if there is a second row, means second level, then that will have 2 elements, and if there is a third level, then it will have 4 elements, and so on. If there is another level, it cannot have less than the maximum of that level. So that's a full tree. Now let's talk about what a heap is. A heap is a tree that is complete, a complete tree that follows a specific rule, and usually it is something like the parent is bigger than the both of the children, or the parent is smaller than both of the children. So these are called max heap and min heap respectively. So this lets us build out heaps in a very efficient manner. If we know how to represent trees using arrays, then it becomes very easy to represent heaps using arrays, because there will never be any holes in between. So whenever there is a hole, you can understand that it's not a tree, so therefore it's not a heap. So when we are creating a heap from an array, let's say we have an array of elements and we want to create a heap from that, there are two different ways we can go about it. There is just the normal create heap way, and there is also one method called heapify. Okay, so in the create heap, what we do is, when we insert an element into the new heap, we will check if its parent is less than, if it is a max heap, we will check if the parent is less than this current element that was inserted, and then if it is, then we will swap both of those. The parent will become the child and the child will become the parent. So the question comes, where do we insert this to check if the parent, check with the parent, right? So what we do is, since our heap is a complete tree, complete binary tree, that means the next element will come at the end of the array. So we can just push our new element into the array, and then we will compare with the parent based on its index. So if the index is 5, then we will take I by 2, so that will be 2, right? So we'll check if the element at the index 2 is less than the element, our current element at 5, and if it is, we will swap, and then we'll go on until we reach the end of the, at the top of the array. So in this way, what we do is, we're building the tree from the starting, right? So the bigger element will start to bubble up when we insert them into the array. And in the case of heapify, what we do is, we will take the first element in the source element, or we have an array, right, that we are converting to a heap. We will take the first element from that heap, from that array, and we will consider that as a complete heap, because it is, right, just one element is a tree and one element is full and also complete. So we can consider that as a heap, and then we will check if it has any children, and the first element will not have any children because it is at index 1. So if we divide by 2, we'll get 0. So we will check if any of the children are bigger than our current element, and if it is, we will swap them. Okay, so that's what we do, and that's a different way of building out the heap. And basically the heapify method is much more efficient, because it does much less swaps and it doesn't have to do as many traversals, so it is much more efficient. So that's a bit about heaps. I also wanted to talk about tries, but I'm already at almost 10 minutes, so I'll stop for now. Thank you.